So I have to wear this. Okay, so now that we have some more people here before we actually start, I'm Professor Brian Lee. Just call me Dr. B, pretty easy going. Who here's used Excel before? A few people have? Okay, so you got the basics down. He's used it a lot, maybe to make some graphs or interpolating some points or stuff like that, no? Okay, so what we're going to go over today, and for some of you at the very beginning, it may be, hey, I already know this. I'm going to start from the very beginning, defining how things work, and quickly build upon that until we get to actually how we're actually going to make your titration curve, as well as interpolate the area to determine your pKa, your 1/2, right? Equivalence point, your 1/3 and 2/3. I'm going to be doing this today on the Microsoft version of Excel. Everything is there in the Mac version except for Macintoshes, or Bill Gates has conveniently hid it upon you somewhere in there because you bought a Mac. At the very end, I'm also going to go over Google Documents. Who here uses Google Documents as their primary? You do? Okay, so you can accomplish all this with Google Documents. All the commands are there. I will walk through some of that. With the exception of a couple commands, they're almost identical. The graphing is a little more of a pain, but it's doable. If you have some experience with it, it won't be too hard for you. Otherwise, it's just a sit and hunt for the correct menu in Google. Okay. So, like I said, if you want to follow along with what I'm going to be doing on the spreadsheet I'm going to be working on, this is it. You can download it. Feel free to work on it while I'm working on it, or don't work on it and just watch and just look. This time is for you. I don't expect this to take the full 2 hours, so if there's going to be questions, we can have questions. If there's something that's really not clear as we plod through it, just let me know. Just raise your hand or say excuse me. If I'm not looking up, say excuse me or something, because I may not see your hand up or whatever. So this is your time. This is for you, okay? Any questions before I start? Nada? Okay. Oh, well, here we go. So how long, when I told you to download from the link, was that already black? Because that would have been funny. Is that too small? If I type in there, are you going to be seeing what I type? Is this fine? Does it need to be increased in size at all? Sure. Is that better? You want it more? Okay. So Microsoft Excel is a good platform for analyzing some data. It is not the end-all be-all for analyzing data. There are other programs such as Igor or MATLAB. Each one of them have a lot of pros and a lot of cons. We're starting with Excel because it's more universally, people have seen it. How many people here have used MATLAB? How many people here have used Igor? Yeah. So people have more access to it. It's in a lot more places, so this is where we're going to start. Now, there's nothing wrong with you doing this in MATLAB or some other system. Just understand that you can do it there. It's just different commands. It's a different environment. You are not stuck here. Okay, so how does this software work? Each one of these little boxes here, I know this is very basic, this is a cell. Each cell is labeled basically by, just like your XY coordinate graphs, except for it is labeled by this top letter, followed by the side number. So this would be cell D3. Really easy, right? So if I want to reference this cell, we're going to talk about D3. This, of course, is going to be E6. You can read it easily up here if you don't want to look over to the sides. So these are columns. Quite often we do a lot of our standard single variable in a column. All your y-dimensional data, such as maybe all your pH. You'll also put maybe in another column all your x-dimensional data, like how many mils of sodium hydroxide you've added to your system. It's nice to do it this way rather than scattered around because there are some tricks in the software that allow you to do the math rapidly rather than plugging it into each and every single cell. So as much as you have a column, you have a row. Those tricks that you can use in the columns, you can also use on the rows. However, you will have to drag on those, but we'll get into that in a few more of our tabs from now. So we can have different data in different areas. These are the tabs down the bottom. So each tab is just a different worksheet. And so it allows you to separate worksheets in your information, but keep them all together in one place. That's all it is, okay? So maybe one document will be for one experiment. One page will be for maybe, say, calculating your NaOH standardizing your NaOH, and then maybe another one will be doing your graphing and your curves. So everything stays together. I don't know what Professor Tauber or Kim do in 7L, but if you take 100A from me, when you do a lab, you are required to turn in this file to show me all your work. It's a lot better to use this than doing calculations with your calculator. If you make an input error or an inappropriate math error, you can see it, detect it, and fix it across a wide amount of your information. This doesn't mean you don't need a calculator. You should always double check what you're doing because sometimes you forget your order of operation and you'll maybe say, okay, well, I want 3 plus 2. I want the average of 3 plus 2. Okay, so 3 plus 2 and then divide by 2. Well, your order of operation is 3 plus 2 divided by 2. Well, 2 divided by 2, order of operation was first. 3 plus 1 is 4. You're not getting the right answer. So calculators are still required to at least check one of the cells that you're doing math in. Always smart. Okay. So clipboard. You have a clipboard, you can do what's called matrix copy and paste. So maybe later you'll have a bunch of data, and I'll show you what I did in a few minutes. You can now take that data and you can paste it. You can just do Control P for paste, but there's a variety of different pastes that I want you to realize. One is just paste it. Whatever's there, paste it. If it's a formula, which we'll talk about in a minute, paste the formula. There's one that's just paste values, okay? So if you have a formula, it's doing some math for you, and it says the answer is 7. If you do Control copy paste, you've pasted the formula. If you do copy paste value, it'll just paste the 7, but you'll lose everything behind there. But if any data changes before it, it won't change. I'll show you examples of that. But just realize there are several different types of paste. You can access them by either right-click and looking under the paste settings here, or up here you can see a variety. If you hover over them, you'll see that this is values, right? 1, 2, 3, it pastes the values. This is just a regular. This is make sure you just paste the formula. Anyway, you get the idea. So also, you may have started your Excel and it looks like this, right? You don't see all the tools. The tool to get to all your tools is just here. You can hide and unhide it here. So if it kind of looks different from mine already, that's to bring up the tools. I know it's really basic for some of you. You guys can zone out for a little while if you've already covered this. Okay, and you can customize your ribbon up here with other things. Good enough. Now, the other thing is that these cells you can format these cells. You'll see I have a variety of columns here. All have the same number in it, right? 1, 2, 3, 4, 5. And 1, 2, 3.50, okay? So what is this format we're looking at? You would select a cell or select the whole column and see what the cells are formatted as. Right now, these are general. All cells start as general. It could be anything, text, a number, anything, okay? Now you can also define these cells just to be a number. So in this case, we will define this row here to be a number. That allows you to put decimal places. So let's say you have an analytical balance, right? And you've weighed out something. And you've weighed out 5 grams. It's exactly 5 grams, right? This goes to 1/10 of a milligram, so it's really 5.0000, right? But if I were to input here 5.0000, which is the data you got, and I hit return, to the machine, those zeros mean nothing. So what you can do is you can tell it, hey, when someone looks over this, I want to make sure that this has 4 decimal places. This is how you preserve that information, because this will not carry over your significant figures. This will not give you that information, so you got to force it to tell you. Of course, you also can use things such as scientific with how many ever decimal places you want. Okay? So you'll notice that maybe if we do format cell scientific and we do 2, you'll notice that number looks changed right down the bottom, the 1.23 times 10 to the 3rd power, right? We only see 3 of those. What happened to the 4, 5? Well, you're just changing the display, because look up top here. It's still there. So don't worry about that. Your number will always be there. If it appears different, it's okay. If you have concerns, double check, okay? Any questions? Clear as mud? It's hot in here, isn't it? Yeah. Okay. So now we're going to talk a little bit about numbers and functions on the 2nd tab here. So this is a number, right? Number 5. I'm going to click on it, and up top in the bar where the data is, you can see there's a 5, right? Now down below, you see another 5, right? But I'm telling you that's actually not a 5. If you click on it, I'm saying this cell equals B4. So I'm actually saying this cell doesn't actually do a number, it's a formula. It equals whatever's in B4. So what will happen to that cell if I change this number? It also changes. Okay? So whatever's in that cell down below here, whatever's in the cell will always reflect what's above it. And that's it. This is your variable. This is just saying go there. And you access this by saying, using the equal sign. That equal sign tells the computer where you're doing a formula. Anytime you see a letter and a number, it's going to refer to a cell somewhere in the spreadsheet. And in fact, not just this spreadsheet, maybe into other tabs of that spreadsheet. Okay? That allows us to do something fun. It allows us to build more complex formulas. Okay? So if you see how I've added a bunch of stuff by accident? I don't want to save that change, so cancel. Okay. Now this cell says it's 2 times the number up top. So if I click on this cell, you can see this cell also equals B4, right? But what's after the B4? You can talk. Oh. It's really easy. I should have brought some candy, because then if you got a right answer, I'd throw it at you, then you'd talk. Right? It's just a multiply by 2. Right? So now you can see how this is going to start doing formulas for us. We're going to be able to put in data and then do math with it. Right? So we can do a variety of things. We don't have to do just one cell either. We can multiply across multiple cells and put in more complex formula. Right? Just remember to use brackets when you want to do things. So maybe you want this cell up top to be, you want the average of the top cell in 2, right? Once again, this goes back to our brackets, right? What's the order of operation, right? Multiplication, division first. That's exactly what this machine does. So if you really wanted to take this average, make sure you use parentheses, right? Clear? Easy peasy? Any questions so far? Good, because I wasn't going to answer them. That was just a joke. Okay, so this allows us to actually do complex math. So right here, we have a bunch of x values, okay? We're going to make a line. Everyone knows y equals mx plus b, right? In fact, we're going to use this equation. Y equals 2x plus 4. So in order to do that, I'm going to say, okay, y equals 2 times x plus 4. Is this correct for order of operations? Would this work? Bueller? Bueller? Would this work, order of operations? Yeah. You know what, though? For me, I always will put them in just in case. Does it hurt? No. Does it help? No. But that's up to you. Okay, so how would we do the rest of these cells? Would we want to put these in every time? No. Okay? So there's this thing called the secret square. I just made that word up, patented. See this little square in the bottom of the corner here? See how my cursor here goes to move, right? It has little arrows. Here, let's see. Here it goes to a little plus sign. Here it's move, move. So if I was doing this, that would move it. Right? So what that does is allows us saying, hey, what I'm going to do is I'm going to take that formula, I'm going to fill it down. And what that does is it says, hey, if we're referencing something here on the left, let's reference the one below it as you go down. So you'll notice that my top one, right? And if you click up here in the bar where your information is, your variables will be highlighted in a variety of colors. The first one will be blue, then the next one will be red. So if it says G8, well, where is that? I got to find it. Well, it'll be highlighted like that blue boxes on the left. So that one references G8, but because we use this, you'll see one references the one to the left. This one references the one to the left. This one references the one to the left, right? And on, right? So now we've been able to write one equation and apply it down. So we've just generated an XY value table, right? Just with putting in one equation. So you don't have to put it in over and over. Okay. So I'm going to show you another trick. The square, if you were up against a bunch of data, I grabbed this last time and pulled down to wherever I wanted. But if the information you are going to be using is to the right of whatever you want to have math done, all you have to do is double click in this. Detects what's on the left and fills down. Okay, so let's do a copy paste. If I took these and I said copy paste, I'm just going to use Control V. Huh, that's weird. Well, we've Control pasted, and what are we looking at? We've moved our variable, right? So it's still thinking whatever this cell is, we're looking at the variable one to the left, right? So there's two ways you can fix this, okay? So you can, well, there's three ways. You can go in here, you can type it, you can highlight it, so you could type in what you wanted. So I could say, oh, it's really G. Or I could just delete it all together and just click the value. Or you can do the other way, which is the easiest way, which is you can drag that blue wherever you want it. And then because you've referenced that, you can use this again to get it back. Okay. Clear as mud? Lots of tricks. That's what I'm trying to get the tricks done before we get to the meat. So let's delete this. Let's say I didn't want the functions. I just wanted this data to move somewhere else, right? So here I'm just going to say paste value. It's those values, right? It's not a function anymore. You've locked that function out. You've just taken the values at that point of time, pasted them somewhere else. Am I going too fast, too slow? No? You guys are too quiet. Okay, so lock values. Is that my next one? I think that comes up later. We'll do lock values later. Okay, so sometimes you might have to make a column that looks like this. You need some X data. You're going to plot something. Let's make some X data. Well, you can go 1, 2, 3. Yeah, I'm not going to do that. I don't have that time in my day, especially if it's going to be a large data set. Now, this machine is kind of smart. It'll say, hey, I detect what you're doing, and I'll just follow 1 down if I drag it from there or I copy paste. It can also be content aware. So if I do 1, 2 and highlight them both, it'll continue down in the way you want. I rarely rely on that. So what's the math function going on the left? Just indexing by 1. Yeah, that's it. Okay. So this cell equals this cell plus 1. Fill that down. That's it. What's the cell above it? And plus 1. What if I don't want them to change? What am I going to do? I want to lock it down. I want to remove that formula. Copy. Paste value. Okay. What about this column over here? How would I make this column? Plus 2. You got it. Rocket surgery. How do I make a row? Okay, what am I indexing by? Right? We already know what this is, right? 5. Okay. So this cell equals this cell plus 5. And the magic square works across too. However, if you double click on it, it will only go down. It doesn't fill out. Just so you know. Okay, now we're going to talk about locking cells. So right now we've seen whenever we drag down, right, if we have a cell, let's say we have this cell, it's 2, and this cell equals this cell, and I drag it down, right? Even though it's showing 0, what it's doing, it's really looking to the one to the left, right? What if I didn't want it to do that? What if I just wanted it to always reference that cell at the top? Well, there's a way to actually lock the value. Okay. So we lock the value with a $sign. That is a don't move. Okay. So when we're dragging down this 2, what's changing in that cell? Right. We're currently at G6 for this 2. right? If I drag it down, what's the next cell below it? G7 or, yeah, right? So G7, what's below that if I keep dragging it down? G8. So I don't want that, so the G is staying the same, right? I don't want that number to change, okay? I want that number to be fixed. So what I'm going to do is in front of the number part, just going to put a dollar sign. Don't change that 6. Whatever you do, don't change that 6. Right? So when I click on this one, what's it referencing? Still the one up above. What happens if I drag this to the right? Well, it's still referencing the top row, but I haven't locked down the letter, right? I said the letter can still change because there's not a dollar sign in front of that. But we can do that also. And in fact, you can actually make that a constant quite often. And you're going to do this a lot when you do work because it makes, and I'm going to show you an example, it makes this a lot easier. So this cell will equal this cell. And I'm going to say, don't change the F, don't change the S. Still referencing that 2, right? And those are all equal to that 2, or 7. Okay? So no matter how you drag, you can lock it down. So let's say you're trying to actually make a large equation, and you want to use variables like, let's say y equals mx plus b. You have a bunch of x information there, and you're going to put in a bunch of y. You can leave your b and m up at the top. That sounds bad. Your m and b at the top with dollar signs in the equation. So no matter what, you can just change these 2 at the top, and it will change your entire spreadsheet just by changing 2 cells. Okay, and we'll do that. Desk. And this is exactly what we're doing here. So this is our m, right? Maybe we'll use this equation first. 2 and our, actually let's go, I usually label m, our m, whoa. Our m will be a 2, and our b will be a 4, okay? I call it make it so they're hot, but, so this cell is going to equal, right, m times x plus b. But I want my m to always stay as an m, and I want my b to always stay as that b, so this cell here, of course, is going to always be referencing the thing I have on the left, and my variables up the top. So if you want to plot a line for whatever reason, oh, I want a line with 0.99275 and an intercept of minus 656, you can get that data, right? Because you've made those 2 cells up the top always constant, not moving, and you're able to do this, right? You're actually going to be doing this, or you're going to be doing some solutions when you're actually plotting the data later for your lab, because you're going to have to do an interpolation of, a section of your curve. Okay. So you can see how that locks. Now let's think about variable locking. We all know what a multiplication table is, right? Who's not done a multiplication table before? You've never done a multiplication table? Yeah, go ahead. Yeah. Right. You got it. right? And you know what? You can put them in a tab on a different page. And all that does is when you reference those, it'll say the exclamation point, the tab name, and then the cell number. And in front of that cell number, you can just put your dollar signs. So you can actually have all your variables on one page if you want, and then change it through the entire document. Yep. Okay. So help me make this. Help me make this multiplication table. Okay, what am I going to put here? This equals what? 2 times 2, right? Good enough, right? Okay, well, let's see how our multiplication table takes place. I don't think that's right. Those are a little big. Okay, so what do we got to do? What do we want changing and what do we don't want changing? Let's start with our variable on the top. Okay, we're going to start with our C5, right? That 2 up the top, we're using that to multiply down, right? Do we want that cell dropping ever? Do we ever want to replace that with C3 or C4 or C5? No, you want it to stay that top value, right? So we don't want the number going down. So we got to lock the number. But when we go across, we still want it to track across the top, right? So let's lock the number down on that one. We don't want it going down. Now what about the other side, the 2 that's red here? We don't want it going across, right? We don't want the letter to get any bigger. But do we want it to read down further in the list? We want the number to get bigger. Okay. So we don't want the... Okay. Make sense? Yeah. Sure. So the y values are just simply the equation we did before. And whenever I change those values up the top, it recalculates. Excel has off to the side, if you find it, anytime you hit enter, it redoes all the calculations in the entire sheet. You can also pause it. Of course, if you paused it, it wouldn't do this. But all these cells say, right, this cell that we're looking at is, hey, take G1, which, you know, happens to be a little bit smaller than 1, multiply it by 1, and then add a minus 654 to it. And so that's all it's doing. It's just a formula. No numbers at all. And the reason I like to pull all the constants out and do that is because let's say you have this complex spreadsheet already done and, oh, that was supposed to be divided by 4, not 2. Well, you can go through and fix every cell, drag down, double check your math, or you just change one number off to the side. I usually leave the entire left 2 columns to define my variables. And make sure when you do define your variables, you have a cell near it that tells you what it is, right? This up top, of course, is the M value. Oh, don't spring over. This is my M value. This is my B value. Quite often, people will just put them off to the side, and you don't know what they are. Luckily, I wasn't going to show this, but there is a way to see what's going on. And it's over here. It's called trace dependence, or trace precedence. So this will tell you the 3 cells that are being used to calculate this number currently on the fly. And then if this is being used for further calculations, which it's not, so let's say the cell equals 9 plus this value. It'll say, oh, that cell's using this information. So if you want to know where your data is going and you're a little confused, you can use those two to see, hey, I'm pulling my information from these cells, and then it's going over here to this one. Oh, well, that's one row lower than it was supposed to be. Okay, I can fix that now. It's a cute little trick. Okay. Okay, we've done our multiplication table. Now we're actually going to start doing some meat. We've got all our tool sets. We're going to add one more called formulas, okay? So right now we've just done basic algebra, right? So now we're actually going to do some other stuff. Now I've got a bunch of numbers here. And let's say I want to take an average of those numbers. Okay, well I can go, okay, this cell is going to equal this plus this plus this. This is going to get tedious, right? Luckily, you can add by going like this. And then, of course, how many do we have? We have 25. So we can do it the long way. Oh, that's not even right. Oh, these are all random. Oh, see? I actually have these being random numbers. Let's see. Control copy. And paste values so they don't change. Okay. So what we're going to do is we're going to use some formulas instead, right? So these are formulas that are already built into Excel as well as Google Documents to help us do what we need to do. So up here you'll see a thing called formulas, f of x. And right now we want to do an average. So in here we'll just type, if we want to do an average, what's a good thing to type in there? Probably average. And you'll see it here. We'll double click it, we'll launch it. Okay. This is saying what numbers do you want to average? It's going to say all those numbers. You can already see where the live answer is there. And say okay. That's one way to do it. You go to the formula, say I want the average formula. Well, let's look at what that looks like. Okay, let's click this cell. What does it look like? Here's what's actually the cell has in it. It says average. And then it has two open parentheses. Inside there are the arguments. It's going to tell you what it's going to do. It's going to average, but it has some directions in there. So there's also a walkthrough version of this. We're going to do this again. We're actually just going to say equals average. You can click it here if you want. Now you see while it's open, it says some information, right? It says, oh, what's your first number? So I can do average of a first number and a second number. Or I can just give it a range by actually just dragging across the whole area. Oops. And closing the parenthesis. Quite often when I have big data sets, there's another trick we can do, and I'm going to show you that in the next one. Does that make sense? Do you see how to get averages of big numbers? How would you check this? Use your calculator. I would say that this algorithm, however, is very well vetted. Now, if you're going to do calculations based on an average, you can do multiple formulas in here. You can go, okay, the average minus, I don't know, the average of just these numbers. I don't know why you do this, but I'm just showing you. You can put multiple formulas together. This can get dangerous sometimes because you don't actually know what's going on with your thing. So I usually like to do an average of that one area, do an average of the second area, and then in the third cell, take the difference between the two so you actually see what's going on in the math. Eventually, later, you're going to become confident enough to just jam them all together. Right now, even I, occasionally, it leads to mistakes, and I'll go, why am I getting a negative number? It should be completely positive, but it's not. So, okay. So here, I want to get an average of, there's 500 things here. So average. Now I can drag all the way down. So let's say this isn't 500. Let's say this is 50,000. Sometimes you'll have data sets this big. Not in 7L, but in other times when you're taking a lot of data fast. It's not unheard of to get that big. So if you know how big your data set is, right, you can go quickly to the bottom and look with your slider. It's 500. So let's just say I'm going to take the average of the first ones. That's not the answer I want. I want them all. So what am I going to do in here? What am I going to change this number to? Yep. You got it. So if you have massive data sets and you're worried about dragging and getting everything or letting up or doing something wrong, just look what the bottom number is and just drag over your range, put them in. Make sense? Okay. We are kind of halfway done. Okay, so you guys are doing a lot of what? Standard, yeah. So no, it's going to take all whatever numbers in there, all right? It's going to add them all together, it's going to divide. Now, however big that number is, it's going to display it. It doesn't care about significant figures. It doesn't care about attention to detail. It's going to give you as much information as you can. In fact, I don't know what the cell's set to, but that's the full number right there. As you see, as I pulled it out, it got bigger. So it's going to give you as far out as it can. It's your job you don't want to be limited with your data. If you're getting truncated data, and you start adding these together, you're going to compound your error. You want full, and then you make the decision where it cuts off, right? You're the boss. You can, but remember, once again, if you format the cell, it's just displaying those numbers. That full number is still there. That's going to be for you to decide later and either put in your lab report or put maybe a big box around it, final answer, or this is the information with the correct number of significant figures. Yep. So, you know, like all computer stuff, this is GIGO, right? You guys know what GIGO stands for? Garbage in, garbage out. So, yeah, I know. It's just going to do, if you program it wrong or you think it's doing something that you don't know it's doing, it's just doing what you told it to. Take the average. I'm going to give you everything. Okay, I did it. Done. Done. Well, did you correct for this? No, you didn't ask me to correct for anything. You said take the average. So, yeah, that's going to be up to you. But we're going to get to that because we're going to do standard deviation next. Dun, da, da, da. I know it wasn't as dramatic as it looked, but okay, standard deviation. So we're going to take these numbers and we're going to get a standard deviation. So maybe the first thing we're going to do, we're going to label a cell. The first step in any standard deviation is what? Taking the average. And once again, right, you can see we have 3 decimal points now. Cool beans. So do you guys remember what the standard deviation is? How we do this manually? Well, standard deviation is what? It's going to be what? This number minus my average, which I do not want to move. Okay, so that's inside. So we've done the math. We've taken the average and the value, and we've taken the difference. Then what happens in the equation? What's right outside that in standard deviation? Square it. So we're going to take this number, and we're going to square it. Awesome. Then what do we do with all these values? Right? What's inside? What's just to the left of that? Sigma, right? We've got to add them all together. So we're going to take all those. So we're going to sum all of these together. Then what? So this is the sum of the squared difference. Okay, so now we've taken them, we've done it, we've squared them, we've summed them all together, and these go over what? N or n minus 1? What's the difference? Sample different versus population, correct. Which one's sample and which one's population? See? N minus 1 is sample, right. Okay. One, two, three, 4, 5, 6, 7, 8. Minus 1 is 7. Okay, then what do we do to it? Now, I know these off the back of my hand. You can always look these up. So now, we've got our standard deviation. Great. There's a quicker way. There's a function. But the reason I'm doing it this way is there's actually a real reason. So if you're just going to do the standard deviation of these numbers, does the standard deviation function give you the population or the sample standard deviation? Well, now you know. It actually gives you the sample standard deviation. Right? The reason I did that out is so you know it gives you the sample standard deviation. Because until then, you didn't know. And then, of course, I've used this in the past, and I'm like, which one does this give me? Right? So this is like using your calculator. You're checking to making sure everything's correct. You can see how I've spread out my calculations. Right? Any questions so far? So now you can do an average of a big data set. Now you get the standard deviation of the data set. Now you can use that standard deviation to tell you how many significant figures you have. Right? Cool beans. The plot thickens. Huh? That was a joke. You guys are awful. Okay. So what I've done here, as you can see, is nothing more than what we've done earlier. I've made a line. Maybe you make a curve. Maybe you make something a polynomial. Doesn't matter. Now, who here follows the stock market? How about this? Who's seen a stock market trace? Right? What does it look like when we go into recession? Yeah, right? Recovery, right? And it gets high. That's a great visualization. Now, if you were just looking at the date and a number, today it's 822. This day is a different number, and just in different numbers in a table. Would that give you that information by looking at the chart? No, right? I mean, oh, look at this day, it was really low, right? This is 600 when days around it were 800. That may give you an idea. But when you're scanning thousands and thousands of numbers, and they're 800, 800, 800, 800, 600, 800, 800, you're gonna skip over that. But with a plot of that information, right, you see it. So there's a lot of value in taking your data and plotting it. And also, it's required. So, I mean, at least for these labs. So we're going to plot this. Now, the plotting software on Excel is a little bit weird. It used to be in the past you would just highlight the X and Y and plot it, and it was really happy. Now it's gotten a little finicky. I'm going to walk you through how to do it easily and correctly the first time. In Google Docs, you can still grab both and do it. It's a lot more forgiving. However, doing the functions on the trend line are more difficult, so it evens out. So to start with, to graph this, we're just going to highlight the Y data we want to graph. Okay? We're going to go over to Insert, because we're going to insert a graph. And we're going to use a scatter point. You can see there's a variety of different types of graphs. If you mouse over them, it'll show you previews of all the different ones. God, I don't even know what that's for. Huh. Well, that's pretty cool. Anyway, that won't show you what you want, right? So we're going to want scatter. And actually, one of these values I fixed because I wanted it out of the line. You can see that. This one I set to 20, just to put that little kink in the line, and you'll see why in a few. So we've plotted our Y data. Is this correct yet? Well, yeah, actually, look at that value of 9s over the 1. Yeah, but that's just serendipitous. It's going to call your first value 1 anyway. In reality, if this were different numbers on the left, totally off. It'd still say 1. So what you have to do is you have to tell this what the real data set is. So you're going to come up to Design, select Data, and there's only one data on the chart, so we're going to edit it. Here you can see what our Y data is. Matter of fact, if I click in the zone, it puts a box on my spreadsheet around the Y data. Right above it is the X data. So I click in the box for X data. I highlight the X data. You can even name this. We're going to call this awesome line. Okay? Okay. So now the information's in there. It's reading both the X and the Y data. And you're able to now customize this graph. Because what is this graph of right now? What am I doing? What am I comparing to each other? You have no idea. This could be kittens versus the number of children in a household. You don't know. So you want to make sure you edit the layout so that you can put in information like kids versus cats, right? Awesome line from the data. You may or may not want this there. You may not like these lines. Just click on them, remove them. So when you make a plot of something, axis. So let's say we were doing this for your data. Let's say we were distributing milliliters of sodium hydroxide. So this would be what? What's a mill? It's volume, right? Volume, NaOH. That's great. That tells us a lot of information about the system, but not all of it. What volume is this? Gallons? Decaliters? Maybe mils. So label it correctly. Though volume of NaOH versus cats would be kind of funny. Not good because I have a cat, but funny. Okay, so make sure you label your axes. Always label your axes. Clear, concise. Usually the type of measurement, volume, length, time. And then the variable is time a second. Is this an hour? Is this a day? Is this a year? Is this a mil? Is this a centimeter? Is this a millimeter? Is this a nanometer? Time, second, microsecond, nanosecond, femtosecond, picosecond. Okay. So now, maybe we want to get some information from this line, right? So you already know what most of the line is what. What's my y equals mxb for that line? What's my M? Should be up there on the left. It's 3, right? And my B is what? 6. Remember, one of these cells I've edited to be lower. It's actually not in the line. So we actually know what this equation for this line is, with the exception of that one point that we've thrown out, right? It's a little dip down. So if we were to ask this, if this was real data and we didn't know what that equation was, let's ask the software to give us its best guess on what's going on. So what you're going to do is you're going to select the data. You're going to add a trend line. So we're going to do a linear trend line. You can do exponential, logarithmic, polynomial, set the order, right? Power equation, but we're going to do linear. We want to know what equation it thinks it is, and how well does that line actually fit the data, okay? This is a Pearson sum score. We'll talk a little bit more about that. Maybe, this is a little bit small in your lab report. Get it nice and bigger. Okay. You can see that most of those points are actually weighting that line up. But is my M 3? No, right? Is it close to 3? Yeah. What about my intercept? Is my intercept 6? Is it close to 6, right? Your data will never be spot on. It'll always have these wiggles in it, right? But now I've known, so if I were just get this at data, I can now give you some information about the system. Well, how quickly will those sea levels rise if this was sea levels? Or how quickly will your house cool down if you were to do a linear curve of power versus temperature in your house? Oh, this will take 2 hours before it gets to sleeping temperature because this last weekend was so hot I sweated in bed after I took a shower. Yeah, it's awful. Okay, any questions on this? Yeah. How do I add the what? Oh, sure. So it winds up, there's a few different ways. The easiest way for doing this is you want to select the chart, okay? Off the left here is what's called a quick layout. And there's a variety of ways you can add information to the chart. I just select the upper left one that actually dropped them in. There is a manual way of doing it, but it's a hunt and a half, so I never do it. I just say format, give me everything. Give me the little table off to the right, it says awesome line. I don't like that. I get rid of it. Give me all the little lines. Give me the stuff on the top and the bottom. So yeah. Luckily, this is a podcast, so if you guys do have these questions, then you don't ask them now. You can go back and look. So this, now with this spreadsheet, you can now copy and paste this into your lab report. Then it's hot, okay? So you can actually double click on it. It'll reopen in Excel and do whatever. I absolutely hate that. Usually I take an image of it and input it in. That's just my way of doing it. Whatever you want to do is up to you. You may like it one way, you may like it the other. As long as you maintain the original, you can always go back and make a correction and then just substitute the image. Yes? Yeah, everything you see up here will be in the podcast. Except for my incredibly gorgeous face, which means anyone who just watches the podcast is out of luck. Okay, now, we were able to get that function line by adding a trend line, linear equation, r squared. Okay. Now, you can add a trend line in Google Docs. It doesn't give you the equation. But you can get the equation the exact same way you can get it in Excel. I'm going to show you. So there's some more functions. One's called linist, which is taking the least squares value between all of these points. So it's giving you a hypothetical line. It draws just a random line and says, okay, I'm this far from this one, I'm this far from this one, and I add all those differences together and I make it positive. It's the residual, how far you're off. That's okay, let's move it a little. Okay, now the number's bigger. Oh, now it's way too big. Oh, now it's getting smaller, now it's getting smaller. And then it finds that minimum spot to actually say this is where the line should be. You can do that by actually typing in a formula. Okay? Anyone want to guess what the formula is? Yep, linist. What's it saying underneath? Known y's. Okay? These are my known y's. Whoops. Comma, known x's. Okay. Constant. Okay. Look here. If I put in false, it's going to drive that line, it's going to look for through the origin. We don't want to drive it through the origin, right? We just want it to float. We don't want it to have to go through 0, 0. If we type in true, it says, okay, let's let it float and let's calculate what b is. So we're going to go true. We want it to calculate. And then lastly is stats. Do you want additional stats or not? You don't need them. If you want to play with them, you can. And so that gives me my slope of my line, my linear regression of the slope that just gives me the slope. Does the slope match what we've done over here? Yes, it does. Okay, how do we get the b squared? How do we get the b, the intercept? Well, there's another command. Can you guys guess what that command is? Haha, it was a trick because I misspelled it. So intercept, known y's. What's it say now? Known x's. There's my intercept from the equation. Well, what's my score of that? What's my r squared? How well does that fit? Known y's. Known x's. So, if you are in Google Docs, you can put the line on there, but you won't get the equation. These are the exact same formulas in Google Documents that will help you find that information should you want it. So all you've done here when you said add a trend line is you had to do some extra formulas for you based on what you plotted. Now, what if you just wanted to do a trend line over a short area? Right? You could just put in that information. We'll show you how to do that. In fact, you can even highlight it separately. Well, as we move on, we will do that. What time is it? 1 hour. Okay, plot 2. What was I trying to do in this one? Make 2 lines. I think we already did some of this in the other one. I think that's what I was trying to do. Okay. So plot 3. We're going to call this an inner. I just want some information on the inside of this, right? So we're looking at this information at x, y. What does this look like? Is there any interesting information in this data? Right? A plot is really going to help. Okay. So let's say we have this rise, 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 and all of a sudden we plateau and we rise. And let's say, I don't know what system we're measuring, but that plateau has information. right? I want to know what that line is just in this plateau. And I'd like to differentiate those points on the graph. This is something you'll do in experiment 2. Sorry. So how are we going to do that? Okay. Let's say we want the points from here, which is data point from 6. Okay, I'll put 6 there. Let's go to this data point. I like this one. 12. So from 6 to 12, I want those to look different. So I would like to put those up there, and I just want to get a line on those points. I'm going to go back to my graph, go back to the data. Okay? I'm going to add some data. The y values are from 6 to 12, and the x values are from 6 to 12. Okay. So now I've highlighted the cells that I want, right? I'm just using the exact same ones. I've made them, they look different. In fact, if I really want to, add a trend line, just linear over that region. I hate these bars. Ugh, they're awful. Okay, once you're in this area, you can select what's going on. Right now we're in the trend line data. So let's go back to this data. We can change the markers. That's not the one we want. We want this marker. Sometimes it's a pain selecting the data you want. There we go. Make them a little bigger. There's a little overkill, right? So now we have a trend line just across some subpoints, right? So now if we wanted to interpolate something in that area, we can do that. You guys know what interpolate means, right? Do you know what extrapolate means? Okay. I have 1, 2, 3, 4, 5, 6, 7 points, right? Let's say I want to know the x, y information, given some x, I want to know the y information of something on that line that isn't one of those points, right? I've got that trend line. I can now interpolate inside the data set. I can say, oh, well, these are all integers, so let's say I have a value of 9.5. I can put 9.5 as x in that equation and tell you what y is. I can interpolate data into there. So I know every point along that line, interpolate. Extrapolate is outside those data points. Extrapolation is fine as long as you know the trend. Can you extrapolate outside these data points that I've listed? No. Why? It's either to the right, it's going to be too low. To the left, it's going to be too high. So there's always a danger with extrapolating out. What's the market going to be? You want to make a lot of money? Let's do the stock market. Let's extrapolate its direction. Whew, that's dangerous, right? Usually, what do you do when you play the market? You look at previous trends, right? Okay? Any questions? Yeah. So what I did is, remember, I added them as data. Remember, I went in and said, here's a subset. Let's go back and look at the data. Remember, I added them as series 2, edit. So it's just these numbers over here, those and those. So I just re-added them in as a small subset of the data. And that allows me just to graph over those points. Even though it's the same data, the computer doesn't care. You've inputted, they could have been the same numbers, just put somewhere else. If you want to copy just those numbers, put them off to the side and regraph them. That's fine too. Absolutely nothing wrong with that. I'm just lazy. Okay. So when you have a titration curve, this is going to help you get those points, and we'll do that. Okay, this is just showing that there's a, depending on your data, there's a variety of different fits you may want to use. An exponential trend line versus a logarithmic trend line. Polynomial, in this case, this data is actually logarithmic. So there's a variety of systems you can use. I don't remember what all these are. That's definitely not a power series. It's probably a second order polynomial. There you go. So remember, just because you have data, right? You guys all know Beer's law, right? What? Right? Absorbance equals path length, epsilon concentration. Right? No? Yeah? Beer's law? Really? The color of a solution? When did they teach that? Anyway, it's linear, okay? It's really linear. But the thing is this, is not all your instruments are linear. At the top of that curve, if you actually put it in an instrument, too concentrated, it winds up curving over. When it gets too dilute, it curves under. So just because the equation is linear doesn't mean the instrument's going to give you a linear response. You'll learn that in 100A if you do analytical chemistry. But still, we're not going to talk about the solver. Now we're actually going to do what you need to do. We've got all the tools now to actually do what you need to do for experiment 2, I think it's experiment 2, for figuring out your titration curve. And we're going to do it. We're going to do a sample calc. Now this data, let's take a look at what it looks like. First I'm going to adjust this, right? My first burette reading is 1.08. That's really 0, right? So this cell actually equals this amount minus that amount. It's 0. We're going to reference that. Okay, what did I do? All I did was take my burette number and shift everything up 1.08. So instead of saying, oh, my first burette reading before I add, oh, it's 1.08, write that down. That's really my 0. I added some. What's my next burette reading? Well, in reality, my first burette reading is 1.08 minus where I started, which is 1.08. So everything, that's the entire list, minus 1.08, and that's all I did. Right? 23.40 minus 1.08. Okay. So what's my Y data here? The pH or the volume NaOH added? pH. Highlight them. Does that look like a titration curve? Looks kind of weird, right? Well, what haven't we done yet? We haven't added the X data. Okay. Looks a lot better now, right? This looks like wicked nice data, huh? Isn't that nice? Yeah? Do you know where this data comes from? When I took general chemistry lab, this is my data set for doing an unknown acid. This is actual data I collected when I was in your position. Yeah, I even still got the old notebook to show it. So yeah, this is what you're going to look like. This is real data. Okay? So what do we want now? We want to know our what? Our endpoint or our equivalence point? Which one? Endpoint or equivalence? What's the difference between endpoint and equivalence point? Endpoint is the color that lets us know when that titration is done. What's the equivalence point? Right, stoichiometric equality, right? And if we're going to measure something, we want to know when it's stoichiometrically equivalent. Where is that on this curve? Right? What do we call a weak acid? It's a buffer, right? So what's going on here? Okay. I've got this pH. I'm adding base. Is my pH changing much? I'm adding base. Is my pH changing through here? No. All of a sudden, I've run out of buffering capacity. I've used up all my acid. So right there where it goes vertical, right there in the very middle, that is exactly where your equivalence point is. Somewhere right in the middle here. It almost looks like this point is right in the middle. Wow, you could just use that. I wouldn't. Very bad. What if you don't have that point? Don't rely on that. Who here is taking calculus? Everyone? Everyone? Yeah? So we know what a first derivative is, right? So what's going on here with the first derivative? First derivative is going what? What's our slope? Is that positive? Positive, 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 and then what? It's going down, right? We have a flip. We're going to a peak, and then we're going back to positive. So it's low number positive to really big positive, back to low number positives. Okay. So we're going to take the first derivative of this. Whoops. Make this a little smaller. There. Okay. Now, there are a couple ways to actually get this number. One is the first derivative. Another one is the change in the first derivative, which is the second derivative. Another way is something called a grand plot, which we're not going to do. And then the last way, and probably the best way, is to actually fit it to an equation. We are not going to do that. It's time-consuming, and it's better left for MATLAB. But titration of a weak monoprotic acid with a strong base will be these equations here. Let's find it. Here we go. So if you could take this equation and fit it to that line, you get all the information. But we are not going to do that. But you can. If you have nothing else to do, you should try. But I wouldn't. Okay. So let's do the first derivative. How are we going to find that first derivative? Well, we want to find our change in y over our change in x, right? So what's our change in y here? It's simply this minus that, right? We're just going to index down one, and we're going to discuss what we're going to do with the x value first. After, I mean. So that's our change in y. What's my change in x? You guys following so far? And the derivative is simply what? Rise over run. That's your instantaneous derivative at that point. That is the slope of the line between those 2 points. So what x value are we going to use for that slope? The left one or the right one or something else? Huh? We're going to use the middle. We're going to go right in the middle. You got it. So our new x is going to be right between these two. So our new x is going to be this plus that divided by 2. Okay. Let's double check our math. Lower minus the upper. Yup. Lower minus the upper. Yup. Derivative of rise over run. Yup. Average of those 2 points. Yes. Now, we're done. So what does this look like? Let's plot it, right? So let's plot go to our chart, say, select data. We're going to add a data set. My y data will be my first derivative. My x data will be my x value for my derivative. So there's my first derivative plotted over my data. Right? What's my tallest point? Well, we can either look in the math on the right, it's going to be this 16.66, or you can just hover over the top mark, you'll see what it is. So our volume of NaOH that we need to know for our equivalence point is 39.87, right? I'm just going to put that here for now. Okay. So 39.87 is our equivalence point. What points are we interested, though, on the left? We want to know what the pH is at half that volume, right? Because what's that? At half that volume, what's that pH? That gives us information on our system. That's the pKa of the acid. We also want to know 1/3 and 2/3, because we can also use those to average together to get our actual pKa. Okay. That means we want information on a couple different things. We want to know what the pH is at 1/3 this. We want to know it at half of that. And we want to know it at two-thirds. So we want to know the pHs of around these areas. We want to know what pH is it at a volume of 11.96. Okay, well, let's take a look. pH of at 11.96. I don't even have an 11. That's not good. Oh, that's not good. How about 19.94? Nope, I don't even have a 19. 26. This is pretty, no, not going to work. Okay. Well, let's look over here. What's this volume point here? How many mils is that? 9.42, right? Is that below the range we're interested in? Okay. So 9.42 is below the range we're interested in. What about up here? We need to go up to 26. This is 30. How about 30? You want 30 or 33? Let's do 33.14. So I've taken 2 points that are outside those, and that area looks pretty what? Looks linear, okay? Well, what have we done before? We're going to add a third thing to this graph again. Select data. Add. I want the y values here from between 9.42, which is here, and 26.58, which is, oh wait, no, 33.14, which is there. So 8 to 17. Okay. Those points. And what can I do with these points? I can add a trend line. So now, I need to know the volume, I need to know the pH at 19.94. Can I plug 19.94 into that equation and get my exact pH I'm looking for? Yeah. Right? Can I do the same with my 26.58 and 11.96? Heck yeah. Right? So now we've put everything together. We've plotted, we've taken a subsection, right? I've shown you how to do a derivative. Right? And this is actually literally and figuratively, it's a figure. That was a joke. You guys are awful. What needs to go on your lab report, right? Make sure you get the pH on there, the correct chart title, right? Label, right? Now I've got 3 things on there, right? And I'm not telling you what they are. So you might want to put a label. A lot of people will use the little thing on the side. The little, I hate this, but I mean, there's nothing wrong with doing this. You can put this little series, you can tell what it is. Oh, the data versus the fit area. I hate that. I like writing in like titration curve, putting an arrow to it, the blue curve, putting a interpolated area, putting it to the arrow to the gray triangles, and then putting first derivative right there and an arrow pointing to the red ones. That way it's like, you really don't have to think. And that's what you really don't want. You don't want your TAs having to think. Because the more they think, the more points you lose. I didn't say that. This is not being recorded. Okay. Is it clear how we finally got here? Clear as mud, all the way from a cell is a letter and a number, all the way up to the final product. It's only been an hour and a half. Are there any questions? Can I help you with anything? Yeah. Oh, totally. Great question. So, what would you like adjusted? You want the height? Select the axis, format axis. Minimum will go -10. Maximum, we're going to go 25. Whatever you want. You want the x-axis? Same thing. And in fact, we're not done. I'm going to go over, I need to do a couple more things in Google Docs for anyone who wants to stay for that. It's the same thing here. You just add in what you want. So let's go -5 to, I don't know, whatever you want, 70. You can change how many tick marks, where you want it, how you want it to cross. There's a variety of ways to do it. Normally, the automatic is pretty good. The only time I usually change it is to like elevate the top a little, because it usually puts that top one too close and it annoys me. But once again, making a chart look good and give you information, there is a little bit of art in it. It's just the way it is. You want it to give the information and a look, and you don't want them to second guess that you don't know what you're doing. Any questions? I'll do a little bit of Google Docs here real quick. So it's the same thing in Google Docs. It even comes up to tell you, what values you want and stuff. So it's the same help. Standard deviation is the same. If you want to go right to formulas, not format, formulas. Function. If you go to more, you'll see that there's a variety of functions. You have to type them in. So you wanted standard deviation. You'll notice that these are not the correct ones. The regular standard deviation is just like in Excel. It's STDEV. We'll give you the same thing. Linist is the same. Your intercept is the same. To chart, to graph, right? So we have a plot. You can highlight these and change your axis, how big they are, and what they're. So, for example, let's see, axis titles. Cat versus kids, I already have that one. Horizontal, vertical axis, you can change them, the font. The series gives you information on the lines. You can select the data. You can add a trend line. It'll add a trend line. It won't give you the equation. You're going to have to do linist and all that to derive it out. Then you can write your own equation. But everything is pretty much the same. Formatting it is just a little more hidden. If you use it a lot, I'm pretty sure it's not hidden to you. To me, I don't use it very much, so it's like I have to hunt for it. Can you get it to look pretty much identical? Yeah, absolutely. As you see, the graphing's the same. You just put in, you can add more data by saying, add more data right at that point. You wanted to add more data. Here, click right here, add more series of data. Just tell it what you want. So that's how you put your interpolated area in if you want. Or you want to overput your first derivative over your titration curve. All the same. Any questions? Yeah? Mm-hmm. Yeah, so remember, when you're doing the first derivative, there's only really 2 points that are interesting unless you're doing fluid dynamics and you're interested in change over time. But when you have a zero, right? What happens when you have a zero as your derivative? Oh, you've got a peak, right? When you have a spike, it's your sharpest change in your derivative. So that means it's right there between those 2 points is where it's going the straightest up. In reality, what I would do is now, okay, so I have a point. If it were me and what I do, this is not necessarily the right answer for you, because the right answer for you is to do what people want for you to do, which is just simple. Okay, so I have a point that's pretty close. I'm going to write that down. I'm going to say I've got this point. My first derivative gives me the second point. If I take a second derivative, what's that going to look like? It's going to go up, and then it's going to go plunge straight down to the negative, and then come up asymptotically again, right? Where that biggest value and smallest value, if you draw a line where that crosses the zero axis, that's another indication. They're all dancing around the point. None is exact, but they're dancing around this point. And now you take all these values, you take a grand plot where it comes in. That's another value. So we have all these different ways of analyzing it. You can take them all, you can average them together, and get more information on how good that number is, assuming it's a random error that's propagating across there. Pretty cool. Yeah, because if you're missing a bunch in the middle where it curves up real quickly, if you're not just doing a drop or half drop and rinse, I don't know if they teach you that here. So if you have your burette, this may not be kosher for your lab. I don't know. So normally you think the smallest amount you can put in is a drop, right? Well, what's neutral water? Adding a little bit of water to your system does absolutely nothing. You can put like half a drop and it hangs right on the tip. Then you take a squirt bottle and you just rinse off that little bit and it plummets down in with water. You get half a drop. You can get a third drop. You take your burette, you take that little thing and you go, and only a little bit's come out and it's still just dangling on there. It won't fall because it's not big enough. Take a little bit of water from a spray bottle, just rinse off downward onto that tip. It takes that little 1/3 of drop and flushes it into your thing. That's how you get such tiny increments as you plot across that area. I don't know if that's part of the lab here for you or not. Do what they say. I'm just here to help you with the mechanics. Cool beans, any other questions? This is not the Excel you're looking for. Do you guys want this filled out version saved and put up online? Okay, I will pass that off to them.
How did you get the new X?
I took the average of the remaining x's. Here, I'll pull it back up.
Sorry.
No, no worries. It's not a problem. What would be a problem is me running out of coffee. Okay, so let's talk about our delta first, right?
Okay.
We're taking the difference between those 2 points, right? We're also taking the difference between these two volumes, right? And this is, we're taking our difference here and here, and we're getting our slope between those 2 points. Right. So, which x value you want to use? You want to use the 0 or the 0.96?
The 0.9.
Right? Well, what we have is, we're taking a point here, we're taking a point here. We're taking our delta height, we're taking our delta, well, we'll call it y, and our x, right? So our first derivative. Now, it's the instantaneous slope between those 2 points, right? Which point do you want to assign it to? This one or this one?
That one.
How about we assign it to a new point right between?
Oh, okay. Just so.
So all I've done is, right, see, look.
Oh.
All I've done is taken the average of those 2 points.
So it comes in the middle.
Right.
Okay.
Makes
That
sense,
makes
right?
sense.
It's the best when it makes sense. You know you got it right.
So that gives you a better.
Right. Well, that's what it really represents.